The Extraordinary Properties of Water, Part 2. Learning Objective. Explain how the properties of water that result from its polarity and hydrogen bonding affect its biological function. High specific heat. The amount of heat needed to raise or lower 1 gram of a substance by 1 degree Celsius. Water resists temperature change both for heating and cooling. Water can absorb or release large amounts of heat energy with little change in actual temperature. If you're ever boiling water for macaroni or something, you will notice that it does take quite a while to get the water to boil. The pan will get a lot hotter before the water starts to boil. Specific heat is the amount of heat that must be absorbed or lost for 1 gram of a substance to change its temperature by 1 degree Celsius. 3/4 of the Earth is covered by water. The water serves as a large heat sink responsible for prevention of temperature fluctuations that are outside the range suitable for life, for coastal areas having a mild climate, and for a stable marine environment. Moderate temperatures on Earth. Water stabilizes air temperatures by absorbing heat from warmer air and releasing heat from cooler air. Water can absorb or release relatively large amounts of heat with only a slight change in its own temperature. Here's a chart that is talking about different events at sea level. We have degrees Celsius, degrees Fahrenheit. So water freezes at 0 degrees Celsius, 32 degrees Fahrenheit. Room temperature, 23 degrees Celsius, 73.4 degrees Fahrenheit. Human body temperature, 37 degrees Celsius, 98.6 degrees Fahrenheit. Water boils at 100 degrees Celsius or 212 degrees Fahrenheit. Evaporative cooling. The cooling of a surface occurs when the liquid evaporates. This is responsible for moderating Earth's climate, stabilizes temperatures in aquatic ecosystems, and preventing organisms from overheating. So even humans, we sweat. When we sweat and the sweat evaporates, then the heat leaves our body. So our sweating is used to remove heat from the body. Water vapor forms a kind of global blanket, which helps to keep the earth warm. Heat radiated from sun warmed the surface of earth. It is absorbed and held by the water vapor. Water is less dense as a solid. Ice is less dense as a solid than as a liquid. Ice floats. Liquid water has hydrogen bonds that are constantly being broken and reformed. Frozen water forms a crystal-like lattice whereby molecules are set at fixed distances. Which is ice and which is water? This one is water because the molecules are closely compacted together. This is ice because you can see that the molecules are spread apart. Density of water. Water is most dense at 4 degrees Celsius. It contracts at 4 degrees Celsius and expands from 0 degrees Celsius to 4 degrees Celsius. The density of water prevents water from freezing from the bottom up. Ice forms on the surface first. The freezing of water releases heat to the water below, creating insulation. And it makes transitions between seasons less abrupt. So for number 2, when it's talking about the ice creates insulation, that is why fish and other marine organisms can live in a frozen lake. Homeostasis is the ability to maintain a steady state despite changing conditions. Water is important to this because it makes a good insulator, it resists temperature change, it is a universal solvent, it is a coolant. We use it in our car radiators as well as in different businesses. They use water in order to cool down their machines. Ice protects against temperature extremes, so it insulates frozen lakes. Solutions and suspensions. Water is usually part of a mixture. There are two different types of mixtures. There's solutions and suspensions. Solution is an ionic compound that dispersed as ions in water. They're evenly distributed. The solute is the substance that is being dissolved, and the solvent is the substance to which the solute dissolves. So, for instance, if we had water and sugar, the water would be the solvent and the sugar would be the solute. You can see in this picture here, they have water, and then they added NaCl, which is sodium chloride, table salt. When they added that salt, then the water molecules started to break that salt apart. And it's because the substance is polar. Suspensions, substances that don't dissolve but separate into tiny pieces. Water keeps the pieces suspended so that they do not settle out. The pH scale indicates the concentration of hydrogen ions, H+. The pH scale ranges from 0 to 14. pH of 7 is neutral. The pH of 0 up to 7 is acidic. The pH above 7, 7 to 14, is basic. So hydrogen ions are in acids, hydroxide ions are in bases. Each pH unit represents a factor of 10 times change in concentration. A pH of 3 is 10 times 10 times 10, or 1,000 times stronger than a pH of 6. So if you go 3, 3 to 4, 4 to 5, 5 to 6. So that's where they got the 3 10s. Acids. Strong acids have a pH of 0 to 3. You can see lemon juice has a pH of 2.5. Tomato juice has a pH of 4. Acids produce lots of hydrogen ions. Bases. Strong bases have a pH of 11 to 14. It contains lots of hydroxide ions, OH negative, and fewer hydrogen ions. Human biology and pH. Your blood maintains a pH of 7.35 to 7.45, so it is slightly basic. The balance of your blood pH is maintained by buffers in blood, breathing, and urinating.